Welcome back everyone. My name is Sagar and we are back here with another video. So today is day 184 of our POTD series and this question name is maximum value. But this is given a medium level question. But I can definitely say that if you ever practice any question of a tree related to its BFS or level of the traversal, then this question is very easy. So first of all, we are given a binary tree and we have to find the largest value in each level. So what is a level? So first of all, if we have some tree, so suppose there is some node and there is this second node. So after that, there are some more nodes after this. So first of all, what is the level? This is our first level, and then this is gonna be our second level. So this is gonna be our third level. So in our first level, we have only one node. In our second level, we have two nodes, and in our third level, we have four nodes. And what we have to do, we have to make an array, and we have to write here all the maximum values in each level. So what is the maximum value in first level? So that is the only value, so it will be the maximum. And what is the maximum value in our second level? So maximum of both values. So we have to write it here in our array, and after that maximum of all four values. It is not necessary that it is a complete binary tree. So suppose there is not any node present here. So we have to just find the maximum value of each level. And how can we find maximum value of each level? So how can we get a level? So first of all, we know how can we traverse in our binary tree. So the simplest method is using a recursive function using BFS. Sorry, DFS, depth first search. But if you don't know, let me just tell you today that we have to use here a queue to traverse in our binary tree using a level order traversal, or we can say it is a breadth first search. Because first of all, we are here at this level, then we are expanding with breadth. So we are just expanding with all the neighbors of this value of all the neighbors of this node. So after that we will be at next level. So after that we will have these both values in our queue. So what we will do after that, we will just expand more breadthwise. So what we will do, we will just get the neighbors of this node as well as this node. So at next level we will have all the nodes that are a neighbor of these two values and they will be at next level, right? So first of all, we have to use here a queue. So we will just make a queue here. And what we will do, first of all, we will just add this value. So this is our first node. So suppose its value is 1, here 2, 3, here it is 4, 5, 6. So first of all, we will just add 1 here. So that is a node. We don't have to add here a data because we will just remove it and we also have to add the neighbors, right? So we will just add here a node. So first of all, this is gonna be our first level. So first of all, we will get the size of our queue because that will define how many numbers of values we have in our current level. So first of all, we will just get the size. So size is 1. So we will just remove one element. So first of all, we will just remove this one. And what we will do, we will just get the neighbor. So, okay. So first of all, we have to just remove this one. So one is here. So we will remove it. So we will just get this one node. And what we will do, first of all, we will check for our current value. That is this the maximum value for our current level or not? And if it is, then we will store it in our maximum variable. Or after that, what we will do, we will just add the neighbors of this value in our queue. So we will just add this 2 and this 3 in our queue, and after that how what we will check how many number of nodes were there in our current level. So we just saw we have only one node in our current level, so we just removed that one value, and after that all the values that are in our queue will be of second level. So after this we will just get how many number of nodes are there in our second level. So there are two number of nodes, so we will just get a queue dot size, so that is the size of our current level, right? So after that what we will do, first of all we will just remove two values. So we don't have to do it like this, that we have to remove two values, three values. We can just use here a loop. So first of all, we will remove two. And what we will do, we will just get either this is the maximum value or not. And we will just add the neighbors of this two. So we will add 4 and 5. So suppose 5 is here and there is 6 and 7. So we will just add 4 and 5 in our queue, 4, 5. So we just removed our one value, and after that we have to remove our second value also. So we will just remove 3 and we will add 6 and 7. So 6 and 7. So 2 and 3 are removed. So we have 4, 5, 6, 7 in our third level. So that is, you can see our third level. So we can just traverse like this. So first of all, we will create a queue here, queue of node, because we also have to add children of some value. So we will just create a linked list here. And we also need an array list for our answers, integer answer. Add a list. And after that, what we have to do, we have to add our current value, that is head node, root node of this tree in our queue, because that is going to be our first level. So after that, while our queue is not empty, so what we are going to do, first of all, we will get the current size, current level size. Current level size is equal to queue dot size, because first of all, we have only one element in our queue, that is the head node, that is the root node. So what we are going to do, we are going to find the current level, that is the current level of current size of this level, right? So after that, we will just remove current size number of elements from our queue. So we can just use here a while loop, while current level size is greater than 0. So we can just use here a minus minus like this, or you can just use it inside the loop. That doesn't make any change because we don't have to use this variable. So after that, what we are gonna do, we are gonna remove this current node from our queue. So we just removed one node, and after that we have to check either this is the maximum. So we will also create a maximum variable out there. So maximum is gonna be 0 because the values of node are starting from 1, as you can see here in constraint. So maximum equal to math dot max of this maximum value and this current dot data. So we always have to compare data, right? So we are using their data. And after that, we also have to add current dot left and current dot right in our queue. So what we are gonna write? Queue dot add current dot left. Queue dot add current dot right. But this current dot left is can be null, and this current dot right is also can be null. So we also have to check either these values are not null, because we are gonna only add the non null values in our queue. So if current dot left is not equal to null, then we are gonna add this value to our queue. And same case for this, current dot right is not equal to null. So if these values are not null, then we will just add neighbor of this one. So neighbor of this one are 2 and 3. And after that, suppose there are no values here. So after that, we added 2 and 3, and we also got some maximum value from our queue. So after this, after traversing in all the values of our current level, so answer dot add, we are just gonna add maximum value in our answer, and at last we can return our answer. So we are just gonna check. So the time complexity of this algorithm is of n, and the maximum value that are present in our array can be the maximum value that can be present in our queue at one time is the number of nodes at last level minus plus the number of nodes at last second level, because you can see 2 3, and when we are removing 2 we are adding 4 5. So yeah, maximum values can be present is the number of nodes at last level. So after that, yeah, so let me just submit it. Time complexity is of n, and we don't have to calculate the space complexity of this answer array, because we have to return it. So that is not extra space, that is compulsory space. So that is it about today, and you just have to remember this thing. So how can we traverse level order in our tree? So that is a very important concept to learn. And that is it about today, everyone. If this video is helpful, go hit the like button and also subscribe to our channel. So do subscribe यार, कोई करते नहीं है subscribe, बस view करते हैं. And you will also get the solution in our DSA repository. So I will just paste it here. So I will just add here a GFG folder, and you can also get other solutions in our DSA repository. So you can just mark it as star so that you won't miss it.